Hello, welcome back to Flipped. Now we are on the final factor which affects speed of reaction, and that is the presence of catalyst. A catalyst is a substance that speeds up reaction without being used up in the reaction itself. Imagine I have this red cube which acts as the catalyst. When I throw it into the reaction mixture, okay, made up of my two favorite reactants, okay, yellow and blue. Alright, when this catalyst is being thrown inside, okay, then these two things react. At the end of the reaction, what I'm expecting is that I should be able to get back my catalyst in its full form, okay, because it should not be used up in the reaction, and that's what a catalyst is. How it works is that it provides an alternative pathway that requires less activation energy. Particles that used to have insufficient energy can now take part in this alternative pathway to react. Okay, this works by decreasing the energy needed for reaction, and this increases the number of particles being able to react. For example, at the beginning, okay, without this catalyst, these two particles cannot react because the reaction threshold, for example, is maybe 100 units. Okay, 100 units of energy to react. Okay, but they do not possess 100 units of energy. How this catalyst can change this is that when it's being added to this reaction mixture, it decreases the energy unit required to react, for example, to 50. Okay, and now both of them have enough energy to react. Okay, and this is how they can go about their reaction. Okay, and so that's why we say decreases the energy needed for the reaction. Okay, by providing an alternative pathway. Okay, this increases the number of particles being able to react, and hence we increase the speed of reaction. How this works in a graph is like this. Okay, this is the energy pathway we have learned about. Okay, y-axis is energy, x-axis is just reaction progress. So we can see that reactants form the first part, products form the second line here. When reactants we want to go to product, it's not a direct line like this. Okay, it's not so simple in life. It actually goes through this huge bump here, and this is the energy required, because you see that this is the y-axis. This is the energy required to cross this boundary to get to products, okay, for the reaction to happen. But a catalyst provides an alternative pathway by doing this. Okay, it decreases the bump height. Okay, so originally we need this amount of energy to react. Okay, this much. Okay, maybe say it's 100. But now when we use catalyst, the reactants just have to follow this green pathway, and now they just probably require around 80 units of energy to proceed. Okay, it decreases the mountain, okay, as you may call it, okay, to make sure that more reactants now are accessible for this reaction. Okay, that's the idea behind it. And this too, you can see that this is a catalyst. Okay, usually they are solid forms, okay, but not always. Okay, for example, catalysts can be chemical in nature. Okay, for example, in the case of vanadium 5 oxide, is used in industry to make sulfuric acid. So these two examples, this one you have to memorize. Catalysts can also be biological in nature. Okay, enzymes which speed up reaction to maintain life. So this is more biology. Okay, but vanadium 5 oxide is an example you have to remember if they ask you to give an example of catalyst. Okay, and that will be all for the fifth factor which affects speed of reaction, and that's catalyst.